So we're going to finish off the last day of the neuromuscular section by talking about muscle fiber types. Much of this will be review from your introductory physiology class, but it's important to understand as we go forward, especially just the more we learn about exercise. So here are two objectives for these 7 or 8 slides that we're going to go over. So remember, we have fast twitch and we have slow twitch. Now, if you took PE 220 from me, we just focused on the two different types, fast and slow. We didn't really talk a lot about what we would call fast fatigue resistant, which is a combination of the fast and the slow. And so each of these motor units has specific characteristics that set it apart from the others. And so the main characteristics that do this are the type of myosin isoform, and really what it comes down to is the type of myosin ATPase, okay, which is shown here. And remember, ATPase is an enzyme that breaks down ATP. And so the faster we break that down, the more muscle contraction that we can have, because cross-bridge cycling will happen more often. What's also important is that the specific type of enzymes that are in the motor unit or in the muscle fibers themselves. Certain enzymes are predisposed to help with anaerobic metabolism, and certain enzymes are predisposed to help with that oxidative or aerobic metabolism. And so ultimately, this is what determines what kind of motor unit there is. Now, in 220, we talked about type 1 and type 2. And if you've read the book at all, they talk about type 1, type 2A, and type 2X. Now, again, this is still putting things a little more simply than what really exists. There are up to 7, 8, 9 different types of muscle fibers, but they have very small differences. And so for this class, we're just going to focus on 1, 2A, and 2X. Okay. Now, like I said earlier, when we think about slow, we think about motor units that have enzymes or ATPase enzymes that break down ATP slowly, whereas fast break it down more quickly, and so we can have more cross-bridge cycles occur. So what we've got here on this figure is we've got the 3 different types of muscle fibers, and we've got glycolytic enzymes here. So phosphorylase, phosphofructokinase, remember that's the rate-limiting enzyme for glycolysis, and then lactate dehydrogenase. Okay, so these ones that are blue. Now notice that type 2A and type 2X have a large amount of these enzymes, whereas type 1 has a relatively small amount. Okay, however, if we go to the oxidative enzymes of succinate dehydrogenase and citrate synthase, the type 1 and the type 2A have high quantities of those enzymes. Okay, and so really what you can see here is that 2A is a combination of type 1 and 2X. It takes the best of both worlds. And so another way to look at this is we've got type 1, type 2A, and type 2X in this figure here. So we break them down into how fast they fatigue, what kind of enzyme activity they've got, and then ultimately what kind of myosin head they've got. And this is primarily determined in part by the ATPase enzyme that's on them. Okay, so even the myosin is different among these 3 different fiber types. And so those are just the primary differences between type 1, type 2A, and type 2X motor units. And just the last thing that I want to talk about is when we recruit them, remember the size principle, we recruit from type 1 to type 2A to type 2X. So type 2X are going to be the last motor units that we ultimately recruit, but they will also be the fastest to fatigue. So when we're unable to complete that max bench press or whatever it is, it's the type 2X that are failing, not the type 1 or even the type 2A.